Today we're going to take a look at function notation for day 6, and in particular we're going to look at the composition of functions. So as a review, see if you can write this in interval notation, pause the video, and then start it once you have finished. So again, interval notation is with the parentheses and the brackets. So our smallest value x can be as -2, and it can include it, so we do the rounded bracket, and it can be anything larger than that, so we'll put infinity. Now the second one, the smallest value it can be is 5, so a rounded bracket for 5. The largest is 25, but 25 is included, so we'll put this closed bracket. So function notation you guys are fairly familiar with. That's that f of x, and we've always talked about f of x is the same as the y value there. Now it can also be written with a semicolon, so f of x, and our function here is 2x plus 1. But more commonly you see it with that f of x. So the first thing we're asked to do is evaluate when x equals 3. So oftentimes you'll see this is f of 3. So we're going to replace our x with a 3. So we end up with 7. Now this next one here, we're asked when our function equals -7. And you'll notice we're not replacing our x with 7. That would be f of -7. Then we would plug it in. But f of x is the same as our y value, so we have the equation -7 equals 2x plus 1, and then we solve this equation. So we have -8 equals 2x, so x has to equal -4. Now we're going to take a look at evaluating some of these. So let's have you pause it and evaluate f of 2, f of 0, and f of -3. So f of 2, we're replacing x with 2. And you'll notice when I'm substituting something in, I always put that in parentheses. So we have 4 plus 8 is 12, minus 3 is 9. F of 0, 0 squared plus 4 times 0 minus 3. So we have -3. And then f of -3. And this is where I like substituting with parentheses. So we can see clearly we're squaring -3 and we're multiplying by -3. So you have 9, let's see, minus 12 minus 3, so we have -6. Now this f of x plus 1, we can replace x with more than one term here. So I'm going to write this here. So we're substituting our x with x plus 1. So every x here will replace with x plus 1. So we have x plus 1 squared plus 4 times x plus 1 minus 3. And now we can simplify this. We know x plus 1 squared is x plus 1 times x plus 1. Distribute, we have 4x plus 4 minus 3. Well, now we can multiply this out. So we have x squared plus x again plus 1 plus 4x. Well, 4 minus 3 is 1. And now we can combine like terms. So x squared, x, and 4x plus 6x plus 2. So f of x plus 1 equals x squared plus 6x plus 2. Next thing we're going to do is take a look at the composition of functions. And I think you did this last year in advanced algebra, but this is when we're putting one function inside another one here. And you'll see it two different ways. Sometimes you see it as f composition of g of x, which is the same as f of g of x, written this way. But then you also, if you had it in a different order, you'd have g composition f of x, and it's g of f of x. Now order matters here. You replace the outer function, so this one on the outside, so in this case f, in this case g, with what's on the inner function. So when we're doing this, if we need to find f of g of x, Here's our outer functions. So I sometimes, but why I'm getting the hang of this, I write out that outer function. Here's our outer function. I'm going to replace that x with g of x. So we're taking our g of x and replacing it. So this is really 5 minus 3. We're replacing that x with x squared plus 4. And we can distribute 5 minus 3x squared minus 12. So we have negative 7 minus 3x squared. Now we're asked to do it the other way, g of f of x. So again, our outside function is that g. So I'm going to write down that outside function. I'm going to replace the x with the inside function. So we're going to take our f here and replace our x. So instead of x, 5 minus 3x squared plus 4. And then again, you could write this out twice and multiply it out. This last part here, we're asked to find f of g of 3. So I'm going to write down what we have here for f of g of x, negative 7 minus 3x squared. And now we're going to replace this 3 with this x with 3. So negative 7 minus 3 times 3 squared. So we have negative 7 minus, let's see, 9 times 3 is 27. So we have negative 34. So let's pause the video and we'll have you try this. Next one. So we're asked to find f of g of x, so we'll rewrite it this way. We'll write down our outside function of f, so we have 2x plus 1. We're going to replace that x with our g function, so we have 2 times x squared minus 2 plus 1. We do some distributing, 2x squared minus 4 plus 1, so our function is 2x squared minus 3. Now it asks us what the domain is. So we know this is a parabola, so our domain would just be all reals. And then we're asked to find f of g of 4. So 2 times 4 squared minus 3. So 32 minus 3, we end up with 29. Now we can take a look at this word problem here. Here's our velocity, given by time squared minus 9 meters per second. The initial velocity, that would be when our time is equal to 0. So we have 0 squared minus 9, which is negative 9 meters per second. Find the velocity after 10 seconds, so we have 10 squared minus 9, so 101 meters per second. And at what time does it come to rest? So we want to know when it's not moving. So we're finding the time, so we want to know when it's not moving at a velocity of 0 equals t squared minus 9. So we can add 9 each time. 9 equals t squared, and then we take the square root. So we have 3 or negative 3 seconds. Well, negative 3 doesn't make sense, so we would have 3 seconds. Now, let's have you work with a partner, and we're going to have you try these, but I'm going to make that a h instead. So letter A, we're finding h of 4, so we're plugging in 4 for x. So 7 minus 2 times 4 gives us negative 1. Letter B is that composition with our outside function of h. And we're going to replace that x with our g. So we have 7 minus 2 times 4x minus 5. And if we distribute 7 minus 8x plus 10, so we have 17 minus 8x. And that was h of g of x. Letter C, when does g of x equal 3? So again, g of x, that's like our y value. So we're solving 3 equals 4x minus 5. And if we solve that, we end up with x is equal to 2. And then letter D, we want to find when they're equal. So we would set 4x minus 5 equal to 7 minus 2x. Let's see, and if we add 2x to each side, we have 6x minus 5 equals 7. Add the 5, so we want to know when 6x equals 12, so x would equal 2. Now the last one we're going to look at, this is a challenge one. We're given this function, and we're asked to find f of 2 plus h. So what that means is we're going to replace our x's with 2 plus h. It's just written kind of interesting here because we have an extra h here. But that's okay. We're still going to take our x's and replace it with 2 plus h. So we got 2 plus h minus 2 plus h all over, put that in parentheses, h. So our numerator, let's see, if we distribute this, this becomes minus 2 minus h. So 2 minus 2, h minus h. So we end up with h over h, which is equal to 1.